Hello everyone. So today we will going to study and see some questions related to some basic concepts of chemistry. So we start first disclaimer slide. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. So let's start with our question number first. The reaction given here is used to produce ammonia. When 450 gram of hydrogen was reacted with nitrogen, 1575 gram of ammonia were produced. What is the percent yield of this reaction? Options are 61.8%, 41.5%, 30.8%, and 20.7%. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be A option. So, how? So, this is the reaction given in the question, and it is given that 450 gram of hydrogen was reacting with nitrogen. So, according to the reaction, we can see that if we calculate the molecular mass of this molecule, it is 6 gram, and it will be 2 multiplied by 17 gram for the ammonia. And if 6 gram hydrogen will producing 34 gram of ammonia. So 450 gram of hydrogen will produce how much? 34 by 6 multiply by 450, which is equal to 2550 gram. So this much ammonia will be produced when 450 gram of hydrogen will be present in the reaction. So actually the ammonia produced is 1575 according to the question. So percentage yield will be 1575 divided by 2550. That is actually what is producing. So theoretical yield upon actual yield multiply by 100 for the percentage, which is equal to 61.76%. So actual yield divided by theoretical yield multiply by 100 and we get our percent yield. So that's why option A will be the correct option. So let's move to our question number 2. A sample of ammonium phosphate, that is NH4 whole thrice PO4, contains 3.18 moles of hydrogen atoms. The number of moles of oxygen atoms in the sample is. The options are 0.265, 0.795, 1.06, and 3.18. You have 10 seconds to this question for solving this question by yourself. After that, we will see the answer. Okay, so the correct option will be answer C, that is C option. So how? Ammonium phosphate has 12 hydrogen atoms and 4 oxygen atoms. So hydrogen and oxygen ratio will be 3:1, and hence oxygen relative to 3.18 mole of hydrogen will be equal to 1.06 mole, because we have given the quantity in mole, so we also calculate it in this terms, 3:1 ratio, which is coming out as 1.06 mole of oxygen, right? So that's why option C is the correct option. Moving on to question number 3. 1 mole of potassium chlorate is thermally decomposed and excess of aluminium is burnt in the gaseous product. How many moles of aluminium oxide are formed? Options are 1, 2, 1.5, and 3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct option will be A option. So this will be the reaction going on. 2 KClO3 will give you 2 molecules of KCl and 3 molecules of oxygen. And 4 aluminium will react with 3 molecules of oxygen will give you 2 molecules of Al2O3. So 2 mole of KClO3 will be equivalent to 2 mole of Al2O3. Therefore, 1 mole of KClO3 will be equivalent to 1 mole of Al2O3. Okay, so this is the explanation. Moving on to our next question, question number 4. Amount of FeSO4NH4 whole twice SO4.6H2O must be dissolved and diluted to 250 ml to prepare an aqueous solution of density 1 gram liter inverse. That is 1 ppm iron 2 positive by weight is. So the options are 3.50 into 10 to the power minus 3 gram, 1.75 into 10 to the power minus 3 gram, 7 into 10 to the power minus 3 gram, 0.35 into 10 to the power minus 3 gram. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be B. How? So 10 to the power 6 gram of solution will contain 1 gram of Fe2 positive. So we convert the 1 ppm Fe2 positive in the grams, and 250 ml will be equal to 250 gram of solution, which we can write 1 by 10 to the power 6 multiplied by 250 gram of Fe2 positive, right? So by solving this and adding the molar mass here, so 250 divided by 10 to the power 6 multiplied by 392 divided by 56 gram will be equivalent to 1.75 into 10 to the power minus 3. That's why the option B will be the correct answer. Moving on to our next question, question number 5. Excess of carbon dioxide is passed through 50 ml of 0.5 molar calcium hydroxide solution. After completion of the reaction, the solution was evaporated to dryness. The solid calcium carbonate was completely neutralized with 0.1 normal hydrochloric acid. The volume of hydrochloric acid required is, given atomic mass of calcium is 40, and the options are 300 ml, 200 ml, 500 ml, and 400 ml. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be the C option. So this is the reaction going on. Calcium hydroxide will react with carbon dioxide, forming calcium carbonate and water. So it is given that 50 ml of 0.5 molar calcium hydroxide reacts with excess of CO2. And from the given reaction, it is cleared that 1 mole of calcium hydroxide give 1 mole of calcium carbonate. So number of millimoles of calcium hydroxide will be equal to molarity into volume, which will be coming out as 25. These are the given amounts. So number of millimoles of calcium carbonate will also be 25. Number of milliequivalents of calcium carbonate will be number of millimoles multiplied by the valency factor. And valency factor for calcium carbonate will be 2. So total is coming out as 50. Now equivalent of HCl will be equal to equivalent of calcium carbonate, and N equivalent will be normality into volume of HCl will be equal to equivalent of CaCO3 is 50, as we have calculated here. So normality is 0.1, and volume of HCl we have to find out. So V will be equal to 50 and V is coming out as 500 ml. So here it is CaCO3. Okay. Yeah. So that's why the option C is the correct answer. Okay. So moving on to our question number 6. Sodium nitrate on reduction with zinc in the presence of NaOH solution produces NH3. Mass of sodium nitrate absorbing 1 mole of electron will be. Options are 7.750, 10.625, 8, 9.875. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, So the correct answer will be the option B. How? So the required equation in this question will be zinc reacting with OH negative will be giving zinc oxide plus 2 hydrogen ion and 2 electron. Similarly, nitrate plus 8H positive plus 8 electron will give you OH negative, 2 molecules of water and ammonia. So from the above equation, since 8 mole of electron are absorbed by 85 gram of NaNO3, therefore 1 mole of electron will be absorbed by 85 divided by 8 gram of NaNO3, which is coming out as 10.625 gram. So the option B is the correct answer. Moving on to our next question, that is question number 7. 1 mole of N2 and 4 moles of H2 are allowed to react in a vessel, and after reaction H2 is added. Aqueous solution required 1 mole of HCl. Mole fraction of H2 in the gaseous mixture after the reaction is. Options are 1 by 6, 5 by 6, 1 by 3, or none of these. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be B. How? So these are the reactions. First of all, nitrogen will form ammonia with the reaction of hydrogen. Then ammonia on reaction with water, it will form ammonium hydroxide. And ammonium hydroxide react with acid, forming a salt and water. So as 1 mole of HCl is required for complete reaction, on the complete reaction, therefore mole of NH4OH it will be 1 mole, right? So now for 1 mole of NH4OH, 1 mole of NH3 will be required, and for formation of 1 mole of NH3, 0.5 mole of N2 and 1.5 mole of H2 will be required. By limiting reagent concept, we have calculated and we have suggested all these things. Therefore, mole of N2, that is unreacted, will be 1 minus 0.5, because 0.5 mole is reacted with the hydrogen to form 1 mole of ammonia, right? So the unreacted mole of N2 will be 0.5 mole, and the mole of H2 unreacted will be, total was 4 and 1.5 was utilized in the reaction, so 2.5 will be left back. So mole of NH4Cl formed finally will be equal to 1 mole. Therefore, the mole fraction of H2 gas mixture will be equal to mole fraction of H2 divided by the mole fraction of H2 plus mole fraction of N2. And it is coming out as 2.5 divided by 0.5 plus 2.5, which is 5 by 6. Hence, option B is the correct answer of this question. Moving on to our next question, that is question number 8. Potassium selenate is isomorphous with potassium sulfate and contains 50% of selenium. Find the atomic weight of selenium. So options are 47.33, 71, 142 and 284. So you have 10 seconds to solve this question, and after that we will see the answer. Okay, so option C is the answer. How? So K2SO4 is isomorphous with K2SeO4. The molar weight of K2SeO4 is given by this formula, where we have taking the atomic weight of Se as X. So if 142 plus X gram inverse of K2SeO4 contain X gram of K2SO4, therefore 100 gram of K2SeO4 will contain X upon 142 plus X multiplied by 100. Okay, mole of or gram of K2SO4. But K2SeO4 contains 50% of selenium, right? So 50% of 100 gram will be 50, and which will be going to equal X upon 142 plus X multiplied by 100. And after calculating the value of X from this equation, X is coming out as 142 gram. Hence, the atomic weight of selenium is 142 gram. We have initially taken X as atomic weight of selenium. So, selenium atomic weight will be coming out as 142 gram. Hence, option C is the correct answer. Moving on to the next question, question number 9. Acidified KMnO4 oxidizes oxalic acid to CO2. What is the volume in liters of 10 to the power minus 4 molar KMnO4 required to completely oxidize 0.5 liter of 10 to the power minus 2 molar oxalic acid in acidic medium? Options are 125, 1250, 200 or 20. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be D option. So KMnO4 reacts with oxalic acid according to the following equation. Equation is given here. So MnO4 negative plus 5 mole of C2O42 negative plus 16 mole of H positive ion will give you 2 mole of Mn2 positive, 10 mole of carbon dioxide and 8 mole of water. So by using this equation, balancing equation, M1V1 upon N1 of KMnO4 will be equal to M2V2N2 upon N2 of oxalic acid, right? And putting the values of M1, V1, M2, V2 and N2 and N1 will be, we are getting this equation. So 10 to the power minus 4 multiplied by V1 upon 2 will be equal to 10 to the power minus 2 multiplied by 0.5 divided by 5. And 2 and 5 are the factor and factor for the KMnO4 and oxalic acid respectively. So V1, we have to find out the volume of KMnO4. So V1 is coming out as 20 liter, right? So hence option D is the correct answer of this question. Moving on to next question, that is question number 10. Hemoglobin contains 0.33% of iron by weight. The molecular weight of hemoglobin is approximately 67,200. The number of iron atoms present in one molecule of hemoglobin are, and we have given the atomic weight of iron is 56. So options are 1, 6, 4 and 2. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct option will be C option. How? So 100 gram hemoglobin contains 0.33 gram of iron, that is given in the question. Therefore, 67,200 gram hemoglobin will contain this much gram of iron, that is 0.33 multiplied by 67,200, and this is divided by 100. So it is coming out as 221.76 gram of iron. Therefore, number of iron atom will be this coming out weight of iron divided by its atomic mass, and it is approximately equal to 4. Hence, the option C will be the correct answer. Moving on to our next question, question number 11. What volume of hydrogen gas at 273 Kelvin and 1 atmosphere pressure will be consumed in obtaining 21.6 gram of elemental boron from the reduction of boron trichloride by hydrogen? An atomic mass of boron is given as 10.8. So the options are 89.6 liter, 67.2 liter, 44.8 liter and 22.4 liter. You have 10 seconds to solve this question by yourself. After that, we will see the answer. Okay, so the correct answer will be the B option. This is the reaction which is going on. BCl3 plus 3 by 2 molecules of H2 will be giving the boron, elemental boron, and 3 molecule of acid. So number of moles of elemental boron will be 21.6 divided by its atomic mass, that is 2 mole. Therefore, number of moles of H2 consumed will be 3 by 2 multiply by 2, that is 3 moles, right? So using the limiting reagent concept, we are stating these things. At 273 Kelvin and 1 atmosphere, that is standard temperature and pressure, 1 mole of ideal gas occupies 22.4 liter. Therefore, volume of hydrogen at NTP will be 22.4 multiplied by 3 liter, which is coming out as 67.2 liter. So this is the correct answer. We can write here as STP or NTP. Okay. Yeah. So hence option B is the correct answer of this question. Moving on to the next question. Question number 12. Density of 2.05 mole solution of acetic acid in water is 1.02 gram per milliliter. The molality of same solution is. The options are 1.14 mole per kg, 3.28 mole per kg, 2.28 mole per kg, and 0.44 mole per kg. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so option C will be the answer. How? The molarity of acetic acid is given as 2.05 molar. So mass of CH3COH in 1 liter of solution will be molarity multiplied by the atomic molecular mass, that is 123 gram. So mass of 1 liter of solution will be 1000 multiplied by 1.02, that is 1020 gram, because density was 1.02 gram per milliliter. So using the density formula, we have calculated the mass of 1 liter solution. It is coming out as 1020 gram. So mass of water in the solution will be the mass of solution minus the mass of this acetic acid. So it will be 897 gram. Therefore, the molarity or the molality of the solution will be 2.05 molarity divided by the mass of the water in the solution in kg, that is 897 multiplied by 10 to the power minus 3, and it is coming out as 2.28 mole per kg. So this is why the option C is the correct answer. Moving on to our next question, that is question number 13. A 15 milliliter sample of a solution is 0.04 molar in SN2 positive and X molar in iron 2 positive. Both are easily oxidized by Cr2O72 negative in acidic solution to SN4 positive and iron 3 positive, and itself reduced to chromium 3 positive. 18 ml of 0.125 molar Cr2O72 negative is required. Thus, X is. So, options are 0.410, 0.205, 0.820, and 1.640. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the answer will be C option. How? So these are the reactions involving in this question, and selenium or SN is converting from 2 positive to 4 positive, losing 2 electrons. So iron is converting from 2 positive to 3 positive, losing 1 electron, and Cr2O7 gaining 6 electrons, becoming 2Cr3 positive. Okay, so milliequivalent of SN2 positive will be 15 multiplied by 0.04 multiplied by the 2 units. It is coming out as 1.2. Milliequivalent of iron 2 positive will be 15 multiplied by X multiplied by 1, because X is the molarity for the iron solution. So it is coming out as 15X, and milliequivalent of Cr2O72 negative will be 18 multiplied by 0.125, that is its molarity, and multiplied by 6, that is its units, the number of electrons which are exchanging, and it is coming out as 13.5. So total will be the sum of 1.2 plus 15x equal to 13.5, and X is coming out as 0.82. Hence, option C will be the correct answer. Moving on to next question, that is question number 14. A mixture contains Na2C2O4 and KHC2O4 in 1:1 molar. Mixture is neutralized by 100 ml of 0.01 molar KOH. Thus, the same mixture is oxidized by what volume of 0.01 molar KMnO4? So, options are 200 ml, 100 ml, 90 ml, and 80 ml. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be D option. So, as given in the question, KHC2O4 will be equivalent to KOH, right? Because in the in the solution of Na2C2O4 and KHC2O4, acid is KHC2O4, and when it will be neutralized, when the solution will be neutralizing by KOH, so acid will react with KHC2O4. So KHC2O4 will be equivalent to KOH, that is 100 ml of 0.01 molar KOH that is given will be equivalent to 100 ml of 0.01 molar KHC2O4. So 1 millimole of KHC2O4 we have calculated. Now this KHC2O4 is equimolar with the Na2C2O4, right? It has a 1:1 molar ratio. So Na2C2O4 will also be 1 millimolar. So total mole for C2O4 will be 2 millimoles. If we write it in the form of equivalents, it will be 4 milliequivalents because 2 the total moles and multiply by the 2, which is the charge on the ion. So it will be coming out as 4 milliequivalents. Now let's suppose the volume of KMnO4 required for the oxidization of this Na2C2O4 and KHC2O4 solution will be V milliliter. So MnO4 reduced to Mn2 positive. Here Mn is in +7 oxidation states. It will be reduced to 2 positive. That is 5 number of electrons that is exchanging from Mn +7 to Mn2 plus will be 5. So by equating the equivalents of both the compounds, we are writing this equation. N1 and V1 is equal to N2 V2, right? So equivalent will be equivalent, and equivalent of KMnO4 will be equivalent of C2O4, because C2O4 will react with the KMnO4, right? So V multiply by 0.01, that is the molarity, and multiply by 5. This will be equal to 4. 4 is the equivalents which we have calculated here, and 5 is the n factor, as MnO4 negative, Mn +7 reduced to Mn2 positive, multiply by volume, and hence from this equation V, that is volume of KMnO4, is coming out as 80 ml. Hence option D will be the correct answer. Moving on to our next and last question, that is question number 15. Weight of 1 liter milk is 1.032 kilogram. It contains butter fat which have density of 865 kilogram meter cubic to the extent of 4% by volume by volume. The density of the fat free skimmed milk will be. Options are 1038.5 kilogram cubic meter, 1032.2 kilogram cubic meter, 997 kilogram cubic meter, or 1000.5 kilogram cubic meter. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option A. So the solution is, let suppose 100 meter cubic milk contains 4 meter cubic fat according to the given condition in the question. Therefore, weight of butter fat in 1 meter cubic milk will be 4 divided by 100 multiplied by 865. That is density. So using the density formula, we have calculated the weight of butter fat in 1 meter cubic milk. It is coming out as 35 kilogram. So weight of 10 to the power 3 centimeter cubic, that is 1 liter milk, will be 1.032 kilogram, which is given. Therefore, weight of 10 to the power 6 centimeter cubic, that is 1 meter cubic milk, will be 1032 kilogram. Therefore, weight of skimmed milk we can calculate by subtracting this weight of milk from this butter fat weight of milk, right? Which is coming out as 997 kilogram. And volume of skimmed milk will be 1 meter cubic minus 0.04. That is the butter fat volume, right? It is coming out as 0.96 meter cubic. Therefore, the density of fat-free skimmed milk will be mass upon volume, that is 997 divided by 0.96, and it is coming out as 1038.5 kilogram cubic meter. So this is hence the option A is the correct answer for this question. Okay. Thank you.